Hi guys, this is going to be a video on calculating the rate from your data. So if we take a look at our data, you'll notice that there are two columns. So we always have the time, and in this case our time interval was half a second, and then we have the pH, right? And so in order to calculate the rate, we measured the pH in order to try and figure out, okay, well, what rate is this thing actually reacting at? Okay, and so what we can do is that we can take a look at where this reaction actually starts happening and calculate the rate law for that. Okay, and so the first thing I'm going to do is I'm actually going to create a graph of this data. And I'm going to create a graph just to kind of get myself familiarized with how this data looks like. Okay, and so the way I'm going to create a graph is I'm going to select cell A1 over here. I'm going to press Control, Shift, and then the right arrow key, and then Control, Shift, and then the down arrow key. And I'm going to press that twice. So what that does is it actually selects all of the data from to the right of my first selection, which was just cell A1. So that's select cells A1 to D1. And then by pressing the down arrow twice, I select the rest of the data that's in this set. Okay, so after I do that, I'm going to press Insert and then Charts. Okay, and so it should bring up something like this. Of course, this isn't what you expect out of this data. We should expect that at some point the pH starts to go up. And the reason why this is the case is because you have this giant red line which is suppressing all of the data. And so that corresponds to the time data. So if we go over here to series, we can actually remove that and we're left with this data here. Okay. Second thing I notice is that there's this giant jump here in the run 1 data, and I don't think that's natural. And in fact, when I did this experiment, there was a jump. And so what I'm going to do is actually try and figure out where that jump occurred. And it looked like it occurred at 600 seconds, 10 minutes. And if you remember, the experiment happened at originally for 10 minutes, and we found out that that wasn't enough to measure the full reaction. So what I'm going to do is, well, since I'm going to assume that the data was running at full speed for the beginning part of this half of the data. So I'm going to actually delete everything before 600 seconds. So if we go back to 600 seconds, I'm just going to scroll through the data. Okay, 600 seconds. We can actually see that there was this giant jump here from 2.27 to 3.22. Okay, again, I'm going to select Control, Shift, right arrow, Control, Shift, up arrow this time in order to get all of the data above that, and I'm just going to delete it. Okay, and then do that. Okay, if we go back to the graph, then we see that. Okay, now, now we have to try and figure out, okay, what was the rate of this reaction? And so the rate of the reaction is actually found by the part that changes the fastest. Okay, the part that changes the fastest. And so over here, if we take a look at the graph, it's not, the pH isn't changing at all. It's staying at a relatively steady 2. However, at some point the reaction actually starts to go up, and then it actually starts to slow down. And so the point at which the fastest change occurs is going to be somewhere in this region of the graph. Okay? Now, I'm going to handle each of these trials separately. So what I'm going to do is take this series data and I'm going to remove one of them. Okay, I'm going to remove one of them. I click the 3 dots and click on remove. Then I'm going to change the data range so that it starts to exclude a lot of the data beforehand. So currently our data range is A1 to D2156. So I'm going to change this to A1000 to D2156, and we'll try and see what happens. Okay, so it looks like if I start the looking at the curve, if I approximate it from, let's say, after this point here, just a little after that point in the data, and I approximate it to, let's say, just before 800, let's say like 775, that seems like it's a good approximation for the data. Okay. If you really wanted to be precise, you would use some calculus, some derivatives, all of that stuff, but for now, just an approximation should be fine. Okay, so I'm going to selectively chop off more and more of the data range by changing the numbers over here. So I'm at A1200, A1300, okay, maybe A1350, that was a little too much, A1340, A1330. Okay, so I know A1330 has that dash. Oops. A14 or A1340 doesn't have that dash. What happened to my data? Hello? Oh no. Oh, I lost my x-axis. Okay, well, technical glitches happen a lot. So let's create a graph again. Insert chart. I'll remove the time data. I'll remove one of the sets of data. And again, I'll start messing with the data range. So I think this was at 1340. I'm going to go a little further because it looks like it's flat around here. Let's say around 700. So maybe I'll go to 1400. Yep. So 1400 starts there. Okay. Then, looks like it starts slowing down at around, let's say here. So I'm going to start chopping off numbers. Okay. So let's say 1556. 1656. Okay, so I know it flattens out at around, we'll cut it off at 775. So 1606, 1556, 1550, 1551, 52. Okay, so 1552. All right, so it should roughly look like a straight line if all things are done and are well and good. So now we have to try and figure out, all right, what's the slope of this line? All right, so the way we figure out the slope is we go to Customize, we go to Series. Down here, there's an option to show a trend line, and that's what we're going to click. Trend lines will approximate this data that's right here as a line. Okay. Then we'll show the r² value, and for the label, we'll use the equation. Okay. So for this particular set of data, the slope is 0.014. Okay. And so the slope is going to represent the rate of our data. Okay, the rate of our data. The blue curve I know refers back to the first trial, so I know for trial 1, the rate is going to be 0.014. Okay, I can be really confident that that's the rate because the r² value is really high. R² refers to something called the correlation coefficient. It says how well correlated is the trend to the data. You can see that the trend line very closely matches the data, and that reflects itself in the r² value. If r² is equal to 1, that means it perfectly correlates with the data. Since it's a little off, it should be very close to 1. Okay. All right, so that's for trial 1, and then I can do the same thing for trial 2. So what I'm going to do is I'm going to copy the graph. I'm going to press Control-C and then Control-V to make a copy of the graph. Okay, then I'm going to go to Edit Chart, and I'm going to play the same exact game, right? So the series here, I'm actually going to remove it. Actually, it might be easier to just create a new graph. So that's what I'll do. Okay. Again, I'm going to select all this data. I'm going to insert a chart. It's going to look like that. So I've got to fix it up. Remove that. The time, and then I believe the first set of data. Yeah, the first set of data was the other one. So we have this. Okay, so we gotta chop off some of the data. Okay, so I think it would be best approximated by maybe around this point, so maybe 600 to 650. So I'm going to go to the other end of the data range and I'm going to start lopping off numbers. So 1156. Oh no, not again. The A1000, D1156. Okay, well, this is broken. Okay, we'll try that again. Insert charts. Time, remove. Nope, remove that. Okay, so we have that. Data range, let's say A1000. Press enter. All right. D1156, no data. That makes sense. 1256, 1356. Okay, so 1356. Maybe I can cut a little more into it. So let's say 1306. Okay. 1306, 1276, 1280. Okay. That seems good enough. Technically, the smaller this range is, the better approximated it is. So maybe I'll cut to 625. So 1260, 1252, 1252. Okay, so A1000 to A1252. Well, I don't like that empty space here, so I'm just gonna do that. A1200, A1201. Oops. Oops. A1201 to, okay, so A1202 to D1252. Seems well and good. Again, let's get the trend line, series, trend line, use equation, show r squared. And I see that the slope of this is 0.0168. Okay, so that's all I need. Trial 2, 0.0168. Right? So the average rate of this reaction is going to be the average of these two data points. So 0.0154. Okay. I know in class that it was a little different. That's because of the approximations, but for now, I think that should be good. All right. Hopefully that helps. Take care, guys.